Welcome, viewers. This is Mr. Odingo. Today I want us to move from the last chapter we discussed, that is our atomic number, mass number, and atomic symbol. I want us to move forward to try to look at what we call isotopes. Now that we know what atomic symbol is, we can be able to understand what isotopes are. Now, I want us to look at three different atoms of carbon. We'll call them carbon 12, carbon 13, and carbon 14. What does these numbers here, 12, 13, and 14, refer to? These numbers 12, 13, and 14 refer to the mass numbers or the nucleon numbers. So the mass numbers here, we all know carbon is the element, carbon, the atomic number is 12. So if the atomic number is 12, then I want us to be able to see atomic number is the same as protons, proton number. So protons are 6, 6, 6 for all of them. Then the neutron number, neutrons, if the mass number is 12, let me write 12 here, the mass number is 13, the mass number here is 14. If I try to write this thing the way I've written it here, we can be able to see that this is the mass number. Let me indicate here mass number. These are the mass numbers of these atoms of carbon. The proton number or the atomic number is 6, the atomic number is 6, the atomic number is 6. The mass numbers are different. In the previous lesson, we are able to see that when you want the neutron number, you subtract the proton number from the mass number. And in this case, we can subtract 6 from 12, which will give us 6. Here we'll take away 6 from 13, which will give me 7. And then I will take 6 from 14, which will give me 8. So here we see that these atoms of carbon, we can only refer to them as atoms of carbon. Why? Because each of them has atomic number 6. So they are the same atoms because we use atomic numbers to identify atoms of different elements. So these atoms here, they are the same atoms of carbon. But what do we see? They have different neutron number and by implication, mass numbers. So we can say that these atoms of carbon are called isotopes. These atoms of carbon here are called isotopes. Number 1, 2, and 3. So this is carbon 12, carbon 13, carbon 14. And I say 12, 13, and 14 are used to indicate the mass numbers. So these three carbon atoms that I've indicated here are called isotopes. So what are isotopes, viewers? Isotopes are defined as atoms of the same element with the same proton number but different neutron number. That is definition number 1. Isotopes are atoms of the same element with the same proton numbers or atomic numbers but different neutron numbers. But someone can say, okay, I want to define isotopes using the mass numbers, not neutron numbers. And therefore, you can also say that isotopes are atoms of the same atomic number, but different mass numbers. Those definitions, viewers, are the same. I always like the first definition, which says isotopes are atoms of the same atomic number, but different neutron number. Why? Because the mass numbers cannot be different if the neutron numbers are not different. So the root cause of the difference in the mass number is actually coming from the neutron numbers. Now, we also have isotopes of magnesium. I can use atomic symbols to indicate magnesium 24, magnesium 25, magnesium 26. These are 3 isotopes of magnesium. Some isotopes have 3 atoms, some have 2. So magnesium here we know that the atomic number of magnesium is 12 because we have defined an isotope. Isotopes are as atoms of the same element with the same proton number but different neutron number or mass numbers. So the atomic numbers are the same, but the mass numbers here are not the same. If I try to get the neutron number, I'll subtract proton from mass number here, which will give me 12. So the neutron number here is 12. If you look at here, the neutron number here is 13, and the neutron number here is 14. So these are isotopes of magnesium. Chlorine, let's look at chlorine. We have chlorine 35 and chlorine 37. Chlorine 35 and chlorine 37. In this case here, we have isotopes of chlorine. We have two of them. We have chlorine 35 and chlorine 37. The atomic numbers we can see are the same because that's actually everything about isotope. They must have the same proton numbers because they are actually atoms of the same element. Then the mass numbers here, or the nucleon numbers here, are different. One is 35, another one is 37. Now, when we try to look at these things here, in this particular neutron chlorine isotope here, the neutrons are 18. But when we try to look at here, the neutrons are 20. So we can actually see that what is different in an isotope, what is actually different in isotopes are mass numbers, and neutron numbers. The proton numbers are the same. So viewer, we want to go further. If someone asks you to be able to explain the similarities of isotopes and the differences of isotopes. So I want us to quickly look at the similarities and differences of isotopes. Similarities, meaning what are the same in isotopes? What are the same? So we want to look at similarities of isotopes. So similarity of isotopes. What are similar in isotopes? Number one, atomic number. So atomic number is always the same, and we know atomic number is the same as proton number. So protons are the same in isotopes. Number two, electron numbers. Electron numbers are also identical. Why? Because we know that atomic number or proton number is the same as electron numbers in any atom. Number three, in other similarities, is chemical properties. Chemical properties. What do we mean by chemical properties? Chemical properties are those chemical reactions. When one element reacts with another one, we know that the chemical reaction, the product and the reactants are different, and you cannot reverse that particular reaction. So chemical reaction, for example, how isotopes or atoms, different atoms of magnesium react with oxygen will remain the same. The product actually will be magnesium oxide. So these are the similarities of isotopes. What about differences? What are the differences of isotopes? Differences of isotopes are, number one, they have different neutron numbers, different neutron numbers. Number two, different mass numbers. Different mass numbers. This is something that we have seen. So the mass numbers are different in isotopes. Number three is the physical properties. Physical properties of isotope. Physical properties of isotopes are also different. Why? For example, if you have to look at the densities, here we can talk about things like densities. We can talk about boiling points, and melting points. and melting points of these particular isotopes are not the same. So viewer, these are the things we have discussed today. And at the beginning of the lesson, I tried to explain using the atoms of carbon what we mean by isotopes, and then we are able to define isotopes as atoms of the same element that have the same proton numbers but different neutron numbers or mass numbers, depending on which one you want to use to define. Later on, we have moved on to try to understand what similarities of isotopes are, and we have said that isotopes have the same proton or atomic numbers, then isotopes have the same electron numbers, and isotopes also have the same chemical properties. Differences of isotopes, we have said isotopes have different neutron numbers, different mass numbers, and different physical properties. Thank you viewers for watching, and welcome next time as we try to look at more information about isotopes.